Hey guys, we're going to do section 8.1, solving systems of linear equations with two variables. Alright, so the first one is determine if each ordered pair is a solution. So if this is a solution, it should work in both of the equations. So let's try 1, 2. So my x-coordinate is 1, my y-coordinate is 2. We're going to plug it into the top one. 2 times my x was 1. And my y was 2. So here we got 2 minus 6, and 2 minus 6 does equal negative 4. So it checks out in the first one. And then the next one we have 2 times x plus y, which was 2. We want that to equal 4. So we've got 2 plus 2, and we do get 4. So it checks out in both. Yes, it's a solution. Next one is 7, 6. We're going to do the same thing. So 2 times 7 minus 3 times 6 should equal negative 4. So we've got 14 minus 18. Oops, sorry, that's a negative 4. And negative 4 does equal negative 4. So it checks out in the first one. And last but not least, 2 times 7 plus 6 should equal 4. 14 plus 6 should equal 4. And here you get 20 equals 4. So it is not a solution for the second ordered pair. So 7, 6 would not be a solution for your system of equations. So you have different methods of solving systems. The first one is substitution. You might wonder, when should I use substitution? If you can ever get a variable alone, if you can ever isolate, or if it's already isolated. So in this case, it's really easy to get y alone. You just subtract 2x from both sides. So now everywhere you see a y, you can plug in negative 2x plus 1. So we're going to go ahead and substitute this into the first equation. So we have 3x plus 2, and then instead of y, we're going to substitute in negative 2x plus 1. Should equal 4. And we're going to distribute. Three x's minus 4x's. We're going to go ahead and subtract that 2 from both sides as well. And divide both sides by negative 1. So now we have our x variable. We're going to plug this in to find y. And you can plug it in wherever you want. I'm actually going to plug it into what we substituted. So here you get y equals negative 2. We said x was negative 2 plus 1. Y equals 4 plus 1. So y is 5. So the solution to that system of equations is the ordered pair negative 2, 5. Moving on. All right, the next one, this was probably taught to you as elimination, eliminating one of the variables, but this book is calling it the addition method. Either way, you want to eliminate a variable. In this first example, it's probably easiest to eliminate x, because I notice all I have to do is multiply that bottom by 2. So I'm going to go ahead and multiply that whole bottom by negative 2. So I'm going to copy the top, 4x plus 5y equals 3. And we're going to multiply the bottom. So negative 4x plus 6y equals negative 14. Make sure you multiply everything. And this is why they call it the addition method. Now we're going to add. So our x's cancel. That's what we eliminated. 5y plus 6y is 11y. And then 3 minus 14 is negative 11. So we get y equals negative 1. And again, you can plug that in whichever one you want to. So we'll plug it into the top. So we've got 4x plus 5 times -1 equals 3. 4x minus 5 equals 3. 4x equals 8. And then divide, x equals 2. So the answer, the solution to your system of equations is going to be the ordered pair 2, -1. And then another example, notice this one, they're not lined up appropriately. So you always want them to line up, x's with x's, y's with y's. So however you want to reorganize it, I'm going to go ahead and bring these 3x's over and bring those y's over. So we're going to add 3x's, we're going to subtract 4y's. So we got 2x. That's just the top one rewriting it. But I'm going to add those 3x's, so I have a positive 3x over here. And I'm going to subtract those 4y's, so I have 8 minus 4y. Now that everything's lined up, you pick how you want to multiply or divide. In this case, you're going to have to multiply both. So I'm going to go ahead and make my x's eliminate. So I'm going to multiply this by 3 and this by -2. So we've got 6x equals 27 plus 9y. And then -6x equals -16 plus 8y. And now we'll do our addition. 6x minus 6x, those cancel. That was our elimination. 27 minus 16 is 11. And then 9 plus 8y gets me 17y. We're going to subtract 11 and divide by 17. And we're going to go ahead and leave that in fraction form. So -11 over 17. So it's a little ugly. Now we're going to plug that in. Oops. We're going to plug that back into one of the equations. And again, it is a little ugly. So let's go ahead and plug it into the bottom one. So we're going to say 4 times -11 over 17 equals 8 minus 3x. So 4 times -11 over 17 is -44 over 17. We're going to subtract that 8, which I'm going to rewrite 8 as 136 over 17 to get that common denominator. Go ahead and subtract. You get -180 over 17 equals -3x. And when you divide by -3, you're going to get, I'm going to do it up at the top here, just so you see. Sorry, I ran out of room. So -180 over 17. If you're dividing by -3, that's the same as multiplying by -1/3. So the negatives are going to cancel out. We're going to get positive. 3 is divisible by 3, and so is 180. So you're going to wind up with 60 over 17. And that is your x value. So x is 60 over 17. So as ugly as that looks, the solution is 60 over 17 and then -11 over 17. All right, moving on. All right, so now we're going to talk about no solution and infinitely many solutions. So if you're talking about a graph, when you get that one solution, that is your intersection. That's where your two graphs are crossing, which is what we've been working with a lot so far. If you get no solution, those are going to be parallel lines. They're never going to cross. They're not going to have anything in common. There's no solution that will work for both of those linear equations. Or it could be the same line and they have infinitely many solutions. Those lines coincide. So just so you kind of have graphically what we're looking at here. So let's go ahead and solve. Looks like we're going to multiply the top by 2. So we got 10x minus 4y equals 8. And then negative 10x plus 4y equals 7. We're going to go ahead and use addition. X's cancel out, y's cancel out. We're left with 0. And then 8 plus 7 gets me 15. Notice 0 does not equal 15. That would be an example of no solution. Those are parallel lines. They are never going to cross. Moving on to the next one, I'm going to go ahead and use substitution because this is already x equals. So wherever I see an x, I'm going to plug in 4y minus 8. So we got 5. I'm going to plug in 4y minus 8 minus 20y equals negative 40. Distribute. 20y minus 20y winds up canceling out, so you have negative 40 equals negative 40. This is the case of infinitely many solutions. Infinitely many solutions. So you don't want to say all real numbers when you do this, because all real numbers do not work. They have to fit into your system. So the way they write it is they say the coordinates x, y, such that x equals 4, y minus 8 works. Or, again, the coordinates x, y, such that 5x minus 20y equals negative 40. Okay, so when you say infinitely many solutions, they have to fit into those equations. All right, and our last example. So businesses use the break-even analysis to make sure that the money they're putting into manufacturing a product is coming back to them by selling it. So we're going to go ahead and find out if when these shoes become that break-even point. So write the cost function. So the cost of the shoes is $300,000 plus $30 a shoe. So that's what it costs to make them. Revenue is what you're making. So my revenue is $80 for every shoe. And we want to find out when the cost and the revenue are going to be the same, right? When are we going to break even? So we're going to go ahead and set those equal. So we got 300,000 plus 30x. We want it to equal 80x. So we're going to subtract 30x and divide by 50. You get 6,000. So that means we need to sell 6,000 shoes. Let's look at the revenue at that point. So 80 times 6,000 is 480,000. So that's your Y. So let's look at this ordered pair. 6,000, 480,000. And when they tell you to explain it, all you're talking about is when I make 6,000 shoes, the cost is going to be 480,000, but I'm also going to be making 480,000, so I'm going to break even. All right, that's all for today. Make sure you get your homework done.